how do we make quantum dots? We have a little video here which just basically demonstrates what we do in our lab every day. We have a beaker, and it just sits inside this heating manual. We heat it up really hot, and then we inject all our ingredients into this reaction, okay? And what's happening here is as the reaction goes in time, we see something very interesting. We see the actual color of these nanocrystals, or these quantum dots, changing. And I think it gets to it right now. You can actually see the color of these crystals changing as they grow in size. So the video goes in a little bit more detail, but here we just have the nanocrystals just sitting by themselves. If I was to take these things and actually put them on a UV lamp, like one of these black light sources we're used to looking at, they actually fluoresce and they produce these very beautiful colors, which are then used for all kinds of applications. So, just to recap, when we start the reaction, when we inject all these materials into this pot, the nanocrystals start out really, really small. They're just these tiny, tiny little crystals, and they're green. And as they grow bigger and bigger and bigger, the crystals themselves actually start to change the color that they emit. So, one thing that we should be very clear about is that there is a difference between the natural color of things and the actual fluorescence, or the light, that they emit. Okay? So one really easy way to look at this is that things are colored because they only absorb and reflect certain parts of the light. So for example, I'm wearing a red coat right now, and when the white lights from all around us are hitting my coat, only the red portions are entering your eyes, and that is why my coat looks red. On the other hand, with fluorescence, it's a very different process. And what it is you actually have to put energy inside to the particular system in order for it to glow, in order for it to give off color. And I have a very simple demonstration here which basically shows that. So what I have is I have quantum dots in one of the vials, and in the other vial I just have some red color. Okay? And what I do is I see they both kind of look red. But when I put them under the actual UV light, when I start pumping them with energy, and it might be hard to see with these lights, but basically the quantum dots will actually be a lot brighter. And I think Alex is helping me with the lights here. But you can see that one of them is clearly a lot brighter than the other. Okay? And the one that's a lot brighter is the one that is actually undergoing fluorescence. And so, to recap, fluorescence actually requires energy to be pumped in before it can give off this very beautiful glow. Okay? And that's what quantum dots really utilize at the end of the day. That's what gives it its special color properties. So, one important question is, how can we actually use this fluorescence? So, in this particular demo right here, what I've actually shown is, and I'll play it again, what's happening is we're actually injecting these quantum dots into a lymph node, and we're able to track where these quantum dots are going inside the human, this happens to be a pig. And if I play it again, we can see that it goes very quickly, and it's very clear. And just to, as a side note, I just want to make sure that, you know, if this was actually to happen on humans, we wouldn't be injecting ourselves with something that's fluorescent green and we'd see this big green thing coming up our arm. Really, what happened is it was something that we couldn't really see, but very specialized cameras were used in order to actually make this image here. But it's extremely clear. Like if we watch it again, we can see just how the quantum dots are moving from one lymph node to the other, allowing us to really map out a very difficult problem. So those are some of the more basic, some of the more applied reasons for using quantum dots. I'm more involved in the basic research, and what I do is I look at fluorescence on the single quantum dot level. So for example, if I was to take this vial right here, and I turn on my energy source, and I put these on, I notice that these things are glowing, but they stay glowing. They don't turn off. Okay? They're glowing no matter what I'm doing. However, if I was to take a single nanocrystal, if I was able to take one out of there, put it under my microscope, and look at it one at a time, I would notice that the fluorescence would sometimes be on, and sometimes it wouldn't. And to kind of demonstrate this, I have a little video which basically shows what I'm talking about. So here, all these blinking pictures right here, they're all individual quantum dots. They're single crystals. So when I look at each of them one by one, I see that they're going on and off, kind of like turning a light switch on and off. And it's very interesting because at the end of the day, my job is to try and understand why does this blinking occur when I look at a single nanocrystal. But if I take this whole vial over here and I hold it up to the light, it always stays on. Okay? And it's a very difficult problem that people really don't have an understanding to, but it holds a lot of power, and it's really worth knowing the answer to. And it's a fun problem. So, just to kind of wrap up, I just thought I'd give you a few points to impress your friends when you guys go home from the Museum of Science today. When you're sitting down at dinner, you can tell them about the things you learned. And in particular, you now are emboldened with 3 new important things about quantum dots. 1, you know what quantum dots are. They're these nanometer-sized crystals, just very tiny crystals. 2, you know how they're made. You basically heat all the ingredients up to 300 degrees Celsius, and you just let them cook. And 3, you also know why they're very useful. From a technology point of view, we can make more efficient LEDs and light sources. And from a bio point of view, we can do these very in-depth biological studies to image cells and other kinds of things, which really are a biologist's dream. And so to conclude, I'd just like to thank a few of my lab members. This is the Buendi group, of which I'm a part. You can kind of see my head pointing out in the back. And to the right is my boss, Munji Buendi, a very smart guy. And this whole internship would not have been possible if it weren't for the Museum of Science and a few funding agencies and, of course, MIT. So with that, I'd be more than happy to take any of your questions, and thank you for your time.